Good afternoon. Today we're going to make an explanation of this exercise using the Gauss law. What is the exercise? A flat plate with an undefined size has a thickness of 2d, which is 2 centimeters. It is uniformly charged with a charge density of rho equal to 2 multiplied by 10 by the power of minus 8 coulombs over square cube meters. What do we need to find? We need to obtain the expression of electric field inside and outside of said plate. What are we gonna do? First, we're gonna need to know what is the charge contained within the plate. To do that, we decompose rho between QE over volume, which is the expression for charge density. That is charge over volume. Volume is gonna be equal to P multiplied by R squared multiplied by height. Why? Because for this exercise we are using a cylinder as the Gauss surface. So what we're gonna do later is we're gonna need to clear QE. That is the charge enclosed, the enclosed charge. To do this, we take the expression of volume divided in area, that is P multiplied by R squared, that is the area of the circle, and we take H, that is the height of this cylinder. After doing this, we get that QE is rho multiplied with A and multiplied with H. Also, we got that H is equal to 2D. That is this length over here. Okay, so what we're gonna do next is we're gonna write the expression of the Gauss law. That is the magnitude of the electric field multiplied by 2y2, because there are two circles over here. So we got two places where the electric field are gonna flow, and the integral of the differential of the area is equal to the enclosed charge over the permittivity of the vacuum. So what we're gonna do next is we're going to solve this integral. So because we got the differential of A integral, then it's gonna disappear and we're gonna get only A. So the magnitude of the electric field multiplied by the area multiplied by 2 is gonna be equal to the enclosed charge over the permittivity of the vacuum. Then we are gonna clear the magnitude of the electric field by taking two areas, take them to divide. So after that, we're gonna replace the enclosed charge with this value over here. That is rho, that is the density of the charge multiplied by the area multiplied by the height. Because we already have an area underneath, we're dividing, we are gonna cancel the areas and we're gonna get this expression. Why? Because rho is 2 multiplied by 10 by the power of minus 8 multiplied by height over 2 multiplied by the permittivity of the vacuum. We continue over here and we divide 2 multiplied by 10 by the power of minus 8 over 2, so we get 1, and this still is multiplied by H and divided by the permittivity of the vacuum. So after this, we're gonna multiply this expression over here, and we're gonna get that H multiplied by 10 by the power of of -8 over the epsilon 0, that is the permittivity of the vacuum, is going to be equal to 0.02 multiplied by 10 to the power of -8 over epsilon 0, that is the permittivity of the vacuum. Why 0.02? Because h is equal to 2d, and 2d is equal to 2 centimeters, but in order to make this exercise properly, we need to convert everything to meters. So 2 centimeters is equal to 0.02 meters. With this expression, we got the expression of the electric field outside of this plate. Now we're gonna do the expression of the electric field inside of the electric plate. How do we do it? Well, we take the same exercise, but we are not gonna replace h. H is gonna be expressed as simply a height that we don't know, but that we know it is less than 2d. So this is the enclosed volume. The enclosed charge is going to be equal to the density of charge, due to the charge density, multiplied by the enclosed volume. Enclosed volume is going to be equal to P multiplied by R squared multiplied by H. So we replace these values in the equation that we wrote over here. So after clearing everything that is gonna be exactly the same, we're gonna have 1 multiplied by 10 by the power of -8 multiplied by h over the permittivity of the vacuum. Of course, in this case, we get the same as over here. We get the expression of h, but in this case, we are not gonna replace it by 0.02. We're only gonna leave it expressed. Why? Because inside of the plate, the charge is gonna change depending on the thickness of the place where we are gonna measure the electric field. Thank you for your attention, and have a good afternoon.